Okay, hopefully this video works this time. This is my take two. So welcome back, everybody. This is week 2 for Algebra 1. A lot of kudos to those who have been, working very hard to transition to this new way of doing things online. So good job, everybody. I know it has not been easy. It certainly hasn't been easy for me. So for this week, which is the week of April 6th to April 10th, I figure we could continue doing a little bit of review. We're going to move to section 5.6. The way I'm trying to design homework assignments moving forward, I'm going to try and make them much more user-friendly for doing things online. It's a huge learning process for me, so do expect me to be trying different things as time goes on until I find something that works the best for us. So I figured for today's lesson, I would just kind of walk you through my slideshow on my computer, show you how I type out my work. That way you know how to easily type out your work on what I'm going to send you for the homework. And your homework, which I will just kind of go to right now so you can see what it's going to look like. Your homework is going to look like the slideshow that I'm going to walk you through. So I'm going to upload this to Google Classroom. You'll see it when you get the notification that also has this video. And when you go to the practice slides, and that's how you know that this is the homework, it says 5.6 parallel review practice. Any slide that says you try, you're going to interact with it. And it's going to look very similar to the slides that I walk you through. So these are my notes again, and this looks exactly like the slide that I was just showing you. So if you're confused on how to do a particular slide for the homework, here's the homework again. Go back, rewatch this video, and look at the slide that looks similar to the one that you are currently completing and use it as a guide. As is usual, if you run into any issues, you can comment on Google Classroom. You can private message me, I believe, on Google Classroom. You can also send me an email if you're not sure what to do. So I'm hoping that this homework assignment is going to be a little bit easier to complete. So let's just go ahead and get started. This week is the last week that we're going to be doing before we go on spring break. My goal for this week is to cover and review the section that we were actually learning before schools got canceled due to coronavirus. So I'd like to do a little bit of review this week. April 10th, there is no school because it's Good Friday. I won't be assigning any work or homework on April 10th. And then the following week is spring break, the whole week. I will not be assigning any homework or assignments that week as well. So this week, we're going to practice for parallel lines. The week we are back is April 20th. I don't know what's going to happen on April 20th. I don't know if we will be back in the classroom then. I don't know if we'll be still doing online learning. I'm going to prepare in the event that we are still learning online. So on April 20th, if we are still doing things online, I'm going to pick it up with 5.6 again and cover perpendicular lines. So if you guys recall, I'm breaking down section 5.6 into multiple parts. We were talking about this when we were in the classroom, that I break it down into parallel, then we do perpendicular, then we kind of do a mix of both. And then at some point, I'll probably be giving you guys a small quiz on section 5.6, assuming I can figure out the best way to do that online. Okay, so let's go ahead and get started. This is something that I actually had you guys take notes on in your notebook. We had a table. You guys might remember drawing that table. I'm going to fill that table out again, just so we kind of have this information. And I'll be uploading this filled out as well as a PDF. So you can kind of look at the PDF if you want, so that way you don't have to watch the entire video again. And also, you can certainly use the video as a resource. So you might recall that parallel lines, they never intersect, they never touch. And if we're looking at slanted lines, so lines that have either a positive or a negative slope, slopes have to be the same in order for them to not intersect. So the best form that we're going to be looking at lines to be in, the best forms are going to be slope-intercept form, y equals mx plus b, or y minus y1 equals m, open parentheses, x minus x1. This is point slope form. So as you can see, I'm typing out my work now. So I'm trying to guide you through how you'll also type out stuff as well. So I'm hoping that this makes doing the assignments a little bit easier now that you can see how to type everything out. So the reason that these two forms are going to be the best to look at, either when you're writing equations for lines that are parallel or determining if two given equations are parallel, is because you can see the slope in each of these forms. We need to be able to see the slope. That's because in order for lines to be parallel, slopes are the same. They have to be the same. And I'm going to put in parentheses, same m value, okay? And here's an example. If I gave you the equation y equals, I don't know, negative 1/3 x plus 7, this would be parallel. If you remember, that's the symbol for parallel. This would be parallel to, I'm going to type it below, excuse me, y equals, well, this is telling me the slopes have to be the same. So I'm going to have to use the same slope, but also the y-intercept has to be different. Oops, it's trying to capitalize that. Y-intercept has to be different. In other words, different b value. So I'm going to go back down here. I'm going to use the same slope, negative 1/3 x, but the b value has to be different. So my b value in that first equation was 7, so I'm just going to make it a different value. I'm just going to make it 6. Okay. Now for the equations that we're going to be working with today, your b value is going to be a very specific value because I'm going to give you a specific point that the line has to pass through. Okay. All right, for horizontal lines, you only have one variable. If you notice in these equations here, I have a y, I have an x. I have a y, I have an x. I have a y, I have an x, I have a y, I have an x. Horizontal lines only have a y. So for example, if I give you an equation where it says y simply equals a number and there's no x, this is going to be parallel to y equals a different number. Here's an example. If I gave you y equals 7, this is going to be parallel to y equals a different number. And it can be any number. Unless I give you a specific point, then it's going to be a very specific number. Okay, so I could say y equals -2. These are both horizontal lines. Okay, let me just show you real quick. How do I do this? How do I insert a line? Here we go. So let's say you had a horizontal line. I'm going to add arrows. Then in order for this to be parallel to another line, it has to be another horizontal line. If I choose a slanted line, they're going to intersect. They're going to cross. I don't want them to cross. Okay? Vertical lines only have an x. So if I give you x equals a number, this is going to be parallel to x equals a different number. For example, if I gave you x equals 4, this would be parallel to x equals a different number. It just can't be 4. So I'm going to say x equals 5. So a vertical line looks like this. It's a straight up and down line. I'm going to put arrows as well. And in order for this to be parallel to another line, in order for this to not cross another line, that line has to also be vertical, straight up and down line. Okay? So this is just a chart that you'll want to refer to if you forget the criteria that lines have to meet in order for them to be parallel. Now, in this first section of the table here, it says that slopes are the same and that the y-intercepts are different. That's still true for vertical and horizontal lines, okay? For a horizontal line, if you remember the skiing slope dude, he says, this is 0 fun. My slope for this line here that my mouse is hovering over is 0. My slope for this line that my mouse is hovering over is 0. They simply are crossing the y-axis in different places. My slope for a vertical line, if you remember Mr. Slope Guy, if he's skiing on a surface that looks like this, he's falling down the cliff and screaming undefined. We have an undefined slope for this line. Same for this line. This also has an undefined slope. And they don't have a different y-intercept, but they do have a different x-intercept. Okay, so they're still meeting the criteria that it says slopes are the same and the intercepts are different. Okay, that's still the case for horizontal and vertical lines. So your first homework slide is going to look like this, and it's going to say, click and drag the matching slope to the equation that is parallel. So I can click on these and move them around. You'll be able to do the same thing on your homework slide. What I want you to do is I want you to read the given equation and find the slope that's going to be parallel to the slope in this equation. So let's take a look at number 1. It says y equals negative 1/2 x minus 3. Well, the question is, what's my slope here? Well, my slope is the number that's touching the x, because this is in slope-intercept form. For lines to be parallel, their slopes have to be the same. So the slope that I want that's going to match this question is going to be negative 1/2. So I'm going to drag this slope. Here's my answer. This slope matches this slope. So essentially, this slide's going to be like a matching game. You're just going to match whatever slope matches the given equation. Let's take a look at number 2. It says x equals 7. Let's say you forgot what type of line that is. That's when you go back to this table and you find the equation that looks similar. Well, if I look at this column right here, this is the one that only has an x. If you notice, this equation only has an x. There's no y. It's only an x. That means it's a vertical line. Well, what's the slope of a vertical line? And you know what? Maybe we should actually add that notation down here. Okay, so I'm going to say m equals 0 for horizontal. M equals undefined for vertical. Well, if your slope is vertical for x equals a number, that's the slope I want to drag and drop. Here's my answer. All right, let's take a look at number 3. What form is this in? This is the weird one that has parentheses and a bunch of plus and minuses. This is actually point slope form, and I wrote this form right here in this table. Where's your slope? Well, it's the number touching the parentheses. If I look at this set of parentheses, though, I don't see anything in front. Now, a lot of students might think, well, if I don't see anything, that must mean it's 0, right? Well, no, remember, if you have a slope of 0, that's a horizontal line. We should only have a y, not an x, if it's horizontal. When I look at this equation, I don't just see a y, I see an x. That means this has to be some sort of slanted slope. It either has to have a positive slope, so these are my options, or it can have a negative slope. 0, I have to eliminate as a possible answer. This has a y and an x. It's going to have a positive or a negative slope. So my slope isn't 0. So let's think about what number is actually understood to be here. There's an invisible 1. I'm going to type that in. Oops. There's an invisible 1. I'm going to highlight this. There's an invisible 1 that sits in front. So my slope here that I want to match is going to be positive 1. Okay? Now let's take a look at number 4. Y equals negative 9. Well, I only see a y, I don't see an x, so it's definitely not slanted like 1 and 3. It's going to be a special line. If I go back to my table and I find the section that has an equation that looks like that, that tells me it is a horizontal line. That means my slope, this is 0 fun if I was skiing on a line that looked like this. That means my slope for this line is 0. So I'm going to drag and drop that answer. All right, so as you can see, I've got 2 answers that I didn't use. Your homework's going to be like that. You're going to have some answers that you're not going to need at all. So be careful. All right, now let's review how to write an equation that is parallel to a given equation. You're going to want to really pay close attention to what form you want to write your answer in. It says write the answer in point slope form. Okay, point slope form is going to be the one that starts off as and I'm going to actually start by typing my work here. This is how you're going to do your work as well. You'll see a text box. Let me go to your homework. You're going to see a text box where it says type your work here. You're going to click it, and you can just type right in here, okay? So same thing. I'm actually going to make my font size a little smaller because I think I'm going to need some space. You can do this too on your homework. You can change the font size, you can change the color. If you run out of space and let's say you're typing stuff and you get all the way down to the bottom, but you're not done with your work and you want to insert a new text box over to the side, simply click on this. It's going to say text box, and you can insert a new text box, okay? So it says, write the point slope form of the equation the line described. I'm going to start with what I know. Point slope has the following equation: y minus y1 equals m, open parentheses, x minus x1, close parentheses. This y, this first one, is going to stay a variable. This y is going to be the y value from my point, okay? This is my slope. This first x is going to stay a variable. This x1 comes from the x value in my point, okay? So I have an x1 and I have a y1. I need to figure out what slope I need for my answer, however. That's where you look at the given equation, okay? Remember, for lines to be parallel, slopes have to be the same. So question is, what's my slope in this starting line? Well, the slope that I'm given, and I might actually just write it off to the side here, the given slope is a -1 that's sitting in front of the x. That's the slope I want to use in my answer, okay? So now I'm just going to plug everything in. It's going to start y minus, and my y value is a -4, equals my m, which is -1. I'm going to open my set of parentheses and type x minus, and the x value is 1, close parentheses. I probably could have left the font a little bit bigger, but that's okay. We're actually not done here. Look at the part that says y minus minus. I can simplify that. I'm going to simplify that to a plus sign. Remember, two negatives back to back make a plus sign. And I'm just going to type everything else exactly how I see it. It's the only thing I could have simplified. I could have, deleted this 1 here and just wrote minus, but you can certainly leave the 1 in there as well if that's more clear to you. Either way is fine. So I could have typed it like this, or I could say y plus 4 equals negative parentheses x minus 1. Either is correct. And one of these would be your final answer, okay? If you want to get real fancy and make your final answer super obvious to me, you could circle it. The only thing is it's going to cover your answer. You're going to want to go up here and say fill color. I want it transparent, but you could put boxes around it if you want to make your final answer nice and obvious. Just so long as you are showing me all of your work and your final answer is clear, okay? All right, so to recap, what we did here is we wrote our formula for the form our answer had to be in. We determined what slope was in the original equation because we have to match that, and then we plugged everything in for our answer and simplified if necessary. I'm going to do another one. Slope-intercept form. Okay, this is not the same form here. Slope-intercept form, and again, I'm just going to start. First, I'm going to make my font size smaller. I'm going to make it 18 to start. If I need to shrink a little bit, I might have to do that, or I could, again, add a text box if I need more space. Slope-intercept form is a different form from the previous question. Slope-intercept form is y equals mx plus b. This one's going to be a little bit harder. I know I want it to pass through this point, and I know I want it to be parallel to this equation. So in order for lines to be parallel, what has to be the same? Well, the slope has to be the same. So the question is, what's my slope in this line? My slope is the value that's touching the x. My slope's 2/3. So I'm going to write that. Slope equals 2/3. I need to use this in my equation. What has to be different, though? My b value. I can't use this as my b value. In fact, you want to ignore when you're doing your work, ignore b equals 4. We don't want to use it, okay? Actually, I'm going to insert this into a text box so it doesn't mess the problem up. So I'm going to insert a text box. And I'm going to say, ignore b equals 4 for your answer. We don't want the same b value. Instead, what you're going to have to do, you're going to have to solve for the b value. And here's how you're going to do that. Step 1, you're going to plug in the slope and the point into y equals mx plus b. Step 2, solve for b. Step 3, plug in your b and m into y equals mx plus b. Okay, so there's some steps to help you. So step 1, I'm going to plug in the slope of 2/3 and the point, -3, 1, into this equation. Instead of y equals, I'm going to write 1 equals, because that's my y value. Instead of m times x, I'm going to do 2/3 times, so I'll do parentheses, I think that's going to be the easiest way to type that out, times the x value from this point, which is -3. And then the plus b is a variable in my equation. So step 2, it says solve for b. Well, this is just a multi-step equation. I'm going to multiply first, and then I'm going to isolate this variable to solve for it. So the question is, what is 2/3 times -3? You may use a calculator if you want. You may take out some paper and work it out. Just so long as you are getting the correct product here. If I multiply 2/3 with -3, and you can double check my mental math with a calculator, you should get -2 as your product. The plus b comes down for the ride. Now the question is, how do I get b alone? Well, if I look at this, this is clearly an addition-subtraction step because I see plus and minuses here. So I know I'm either going to need to add the 2 to get the b alone or subtract the 2. So the question is, what's the inverse of this? Well, the inverse of a minus is a plus. So I'm going to add 2 to both sides. I'm going to do plus 2 here and plus 2 here. These 2's are going to cancel out. You can even draw a line through it if you want to. You don't have to do this, but I'm going to do it to show you. Those 2's are going to cancel out. And finally, I just add here to get my b value. 1 plus 2 gives me 3. I bring down my equals. B is now alone. Okay, whew, a lot of work here just to get our b value, huh? So I look back over to my steps. I'm still not done. It now says, for the final step, plug in your b value, here it is, and your m value, here it is, into y equals mx plus b. And as I mentioned, it looks like I've run out of space, so I'm going to add a text box here off to the side for my final answer. It's going to read y equals, my m goes first, which is 2/3, 2/3 x, and then my b value goes last. It's +3, so I'm going to write plus 3. Here's my final answer. I'm going to draw a little box around it to make it nice and obvious. I'm going to make it see-through so we can actually see the answer. All I do is I click this little bucket and click transparent. And voila, I've got a box around my final answer. All right, let's keep going. These are actually pretty easy ones, like number 3. It says write the equation of the line described. It's got to pass through this point, and it's got to be parallel to y equals 11. What do you notice is missing from this equation? An x. So the only thing that's here is a y. Let's go back to our table. Y equals a number, give me y equals a different number. Now, this is going to have to be a specific y value. Specifically, it's got to be the y value from that point. So your answer here is going to be another horizontal line, but it's going to be y equals the y value from that point. Y equals 6 is your final answer. I'm going to put a box around my answer here. Here's my final answer. This is all you have to do. If I give you a horizontal line, You give me a horizontal line. If I give you a slanted line, it's going to be a little bit harder, but horizontal lines are quick. If I give you y equals a number, you give me y equals the y value from that point. Same thing for x equals a number. This is a vertical line. This is going to be parallel to another vertical line. So if I give you x equals a number, you give me x equals the x value from that point. Done. These two lines are parallel. They're both vertical lines. They're never going to intersect. Here's my final answer, so I'm going to put a box around it. Again, you don't have to do this, but I'm going to maybe do it moving forward just so you can see how. Make it transparent so we can see through. All right, standard form. Do you guys remember standard form? That's the one with the ABCs and all the rules. So standard form, I know that's the form my answer has to be in. And again, I'm going to make my font a little bit smaller. So I'm going to start by writing the formula. It says write the standard form equation of the line described. Well, standard form is this. Oops. AX plus BY equals C. And we learned a couple of rules for standard form. I may actually write them under here. Standard form rules. Oops. Standard form rules. Rule number 1 was that A, B, and C have to be integers, meaning they can't be fractions or decimals. So no fractions, no decimals. Rule number 2 was that A has to be positive. And I mentioned that some textbooks don't consider this to be a rule. Your final exam does consider it to be a rule, so I teach it this way now. I never used to teach it that way because the textbook does not, but because your final exam has problems where the A value has to be positive to get the correct answer, I've started to teach it this way. There is another rule that says A and B can't be 0 simultaneously. We're not going to have to worry about that, so I'm not going to list that as a rule. I've given you some steps. In fact, let me actually change this color so that way it's, here we go. I've given you some steps that you can follow to help get your answer. It says step 1, write an equation in point slope form, because you can't write an equation in standard form directly. This is one of the downsides of standard form. Standard form takes quite a bit of work. We have to actually write it in a different form first and then convert it to standard form. So it says first write an equation in point slope and then convert it to standard form. Okay, so I'm actually going to write near here that we're going to need this form as well. Y minus y1 equals m parentheses x minus x1. So this is actually the form that I'm going to start in. And the reason why I need to start in this form is because I need the same slope. I can't just plug this negative 1/4 in to standard form because none of these values are the m value. A is just a number, B is just a number, C is just a number. None of those numbers are the slope, okay? So I'm going to start by writing my equation. It's going to start as y minus, and I'm going to substitute the y value from this point, which is -4, equals. My m is simply going to be the m value from this equation. My m value is here, -1/4. So I'm going to type that in, -1/4, and I'm going to open my parentheses. X minus the x value from this point, which is 5. Okay, so to convert this to standard form, there's a couple things that I need to get rid of. One is I need to get rid of these parentheses, right? If I compare these two equations here, I don't see any parentheses in standard form. So I'm going to do that first. To get rid of the parentheses, I'm going to distribute this -1/4. That means I'm going to multiply this outside term to the x, and I'm going to multiply this outside term to this number here. Again, you can use a calculator. I highly suggest that if you're going to use a calculator, make sure that everything's in fraction form. If your calculator is doing it as decimals, you may want to work this out on paper so that way it's in fraction form. And the reason why is I personally find it easier to clear fractions rather than decimals. Okay, so let's keep going here. I'm also going to simplify these double negatives. So my next line of work, I'm going to write y plus 4 equals, and I'm going to distribute. Negative 1/4 times x is just negative 1/4 x. Negative 1/4 times negative 5, well, the two negatives are going to give me a plus. And then 1/4 times 5, if you work this out on paper or using a calculator, that's going to give us 5/4. Okay? All right, so far so good. Now I need to make sure that the x and the y terms are together and the constant is by itself. That means I've got to do some work here. I've got to move this x term over to the left, and I got to move this constant over to the right. So let's go ahead and do that. In order to move the x value over to the left, you're going to either add or subtract it. So if I look at the sign in front of the x, it's a negative. That means to move it, I'm going to add it to both sides. Plus 1/4 x on the left, plus 1/4 x on the right. These are going to cancel. And here's what I'm left with. Now this term cannot be combined with the y. They don't have the same variable. They're not like terms. It cannot be combined with the 4. The 4 doesn't have an x, so all I can do is just write everything next to each other. So I've got a 1/4 x, I've got a positive y, and I have a positive 4. Here's what I still have on the right. I have a 5/4. That's all. That's still there. I haven't taken care of that yet. That's what I'm going to do in my next step. I'm running out of space here, so here's what I'm going to do. I'm going to copy this. I'm going to insert a text box right here, and I'm going to paste it. And I'm going to keep going. All right, so my x and y are on the same side. That's good, but I need my constant over to the right. So in my next line of work, I need to get rid of this plus 4. The opposite of adding 4 is to subtract it. I'm going to do the same thing over here. These are going to cancel, so I'm going to draw a line through them. Again, you don't have to do this part where you draw a line through the terms. I'm just doing it to make my work even more clear. And here's what I have. I have a negative 1/4 x plus y equals, and now I've got to combine these two. So in order to do that, again, you can use a calculator if you're really good at using a calculator and working with fractions, or you may want to take out a piece of paper and work it out there. In order to add and subtract these two fractions, they have to have the same denominator. Well, my negative 4 currently has a denominator of 1. They don't have the same denominator. So what can I do to get the same denominator? Well, I'm going to insert a text box. I could multiply. Actually, I probably don't need to multiply here, or excuse me, I probably don't need to insert a text box. I can probably just do this off to the side here. I can multiply this fraction, top and bottom, by the denominator that I need. So I can do this times 4. Let me see if I can do this underneath. We're learning here. We're learning the easiest way to type this out so that it's clear. Miss Lorette is learning too, so have patience with me. You know what? I will insert a text box. I think it's going to be more clear. The reason why I don't want to hit enter is because it's going to push this down. I don't want that. I'm going to just insert a new text box, and I'm going to say times 4. I'm just using parentheses. Times 4 to the top and bottom. Okay? And I'm going to actually show my work off to the side here. You're not going to need to do all this on your slide. It's highly encouraged that you do all of this on paper, and you just pick up here whenever you get your final answer. But I'm going to show you the work just so it's clear how I'm getting this fraction. Okay? So I now have 5/4. That hasn't changed. And instead of subtracting 4 over 1, I'm going to multiply and get my new numerator. That's going to be a negative 16. 4 times 4 gives me 16. And my denominator, 4 times 1, gives me 4. Now I can subtract these numerators and get, well, 5 minus 16 is going to give me a negative 9 over 4. Correct? Is that right? Let me just double check my mental math here. 16 and 5. 5 minus 16. Oh, nope, that's not right, Miss Lorette. Let's fix that. Uh-oh. So this is actually a good opportunity to show you how to fix this. Do you see how I accidentally just deleted my text box? If I just go up here and I hit the undo button, it's going to bring it back. Okay, so if you accidentally delete something and you're like, oh no, all my work is gone, go up here, hit the undo button. Okay, so I'm going to subtract that, or delete it rather. It's a negative 11. Okay, so that means I have negative 11 fourths. And it looks like all of the terms are in the correct place now. I've got the x and the y on the left. That's what I want. And I've got my constant on the right. Question is this done? Is this in standard form? Well, let's go back to the rules to see if it meets all these criteria. My a value and my b value and my c value have to be integers. Right off the bat, that's not an integer. Neither is this. It also says that a has to be positive. Here's my a value. It's not positive. So I need to take care of both of those things. So I could do both of these as 2 separate steps, or I could attempt to get rid of it all in one step. I'm actually going to try and get rid of it in one step. So I'm going to clear the fraction, and I'm going to clear this negative. That means that I'm going to have to multiply every single term by a number. So in order to clear the fraction, I need the LCD. Well, look at all of your fractions. What's my LCD for both of these fractions? My least common denominator. It's going to be 4. Okay, they're both the same denominator. So my LCD is going to be 4. And I need to clear this negative. How do I clear a negative with multiplication? Well, a negative times a negative gives me a positive. So I'm going to take this entire equation, and I'm going to multiply every single thing. Let me make this text box wider. I'm going to multiply every single term by a negative so that this negative cancels, and by the LCD of 4. Make it a little wider. There we go. So it's kind of like the distributive property. I'm going to take this negative 4 and multiply with this term. I want to make sure that it's inside the text box. There we go. Negative 4 times negative 1/4, that's going to give me a positive 1. Negative 4 times plus y is going to give me negative 4y. Negative 11 fourths times negative 4, those two negatives are going to give me a positive, and these two 4s are going to cancel, and I'm left with a positive 11. Now let's check again to see if it's finally in standard form. My x and y are together, my constant is alone. Everything is an integer, and the a value is positive. Here's my final answer. So I'm going to draw a box around it. This might be a slide where it's a good idea to draw a box around your final answer. I'm going to make it invisible so that way we can see through it. Phew, this is quite a lot of work. Okay, so just to recap what we did here. I started by writing my equation in point-slope form. I then moved the x term to the left. I moved the constant to the right. I then cleared any fractions, and I ensured that the a value was positive. Let's do one more like this because in my opinion, this is the hardest type of problem. And I'm actually going to copy these rules as well. I didn't put that to start with, but I will now. Standard form rules. I don't think I have the rules listed in your homework slides, so I highly encourage you to, again, rewatch this video so you can see them or review the PDF for the notes that I'm going to be uploading. All right, so I'm going to click. I'm going to make my font size a little smaller. As you can see, we're going to have a lot of work that we're going to show here, so I want to make sure that I'm not writing too big. It says, write the standard form of the equation of the line described. It's got to pass through this point, and it's got to be parallel to this line. Well, first and foremost, standard form is going to be this. AX plus BY equals C. Step 1, write an equation in point-slope form. That means I want to start with this form. Y minus Y1 equals M, parentheses X minus X1. I need the same slope. Here it is. My slope is 4, so I need the same slope. And I need to plug in this y value for y1 and this x value for x1. So using point-slope form, I'm going to write that equation again, but with numbers substituted. It's going to read y minus, here's my y value, -3, equals m. Here's my m value, has to be the same, 4. I'm going to open parentheses and type x minus, and then my x1 is going to be -1. Couple things I can simplify. I can change these double negatives into pluses. I'm going to do that now. That's all I'm doing. I have a double negative here, that makes a positive. A double negative here, that makes a positive. All right, and then I now have to convert this point-slope equation into standard form. Before I do anything, before I move any terms around and before I try to clear any fractions that I may see, fortunately we don't see any here, but before you do any of that stuff, you gotta get rid of the parentheses. To do that, you distribute. The y plus 3 is gonna stay the same. I haven't done anything there yet. To distribute, I multiply. 4 times x is just going to give me 4x. 4 times 1 is just going to give me 4. Now I need to move some terms around. I want the x term to be moved over to the left, and I want this constant to be moved over to the right. Remember, to move terms from one side to the other, you're going to add or subtract it. So if I want to move this x over to the left, look at its sign. It's positive, so I subtract it. I'm going to subtract a 4x from the left, a 4x from the right. These are going to cancel. And I've run out of space, so I'm going to insert a new text box over to the side here so I can keep going. So here's what I'm going to have. Again, I can't combine this 4x with this y. They're not like terms. I can't combine this 4x with this 3. They're not like terms. All I can do at this step is write them all next to each other. So I've got a -4x, I've got a positive y that's still on the left, and I still have a positive 3 on the left. On the right, all I should have now is this positive 4. All right, we're getting closer here. I still need to get my constant on the right. To do that, I look at the sign. It's +3. To undo it, I do -3. I do it to this side as well. These are going to go away. Here's what I'm going to be left with. I still have a -4x and +y on the left. On the right, 4 minus 3 gives me 1. So let's take a look at what we have here. It looks like all the terms are in the correct places. Let's ask ourselves, is this in standard form? Well, a, b, and c have to be integers, which they are. I don't see any fractions or decimals, but a has to be positive. So I still need to get rid of this negative here. And just like I did last time, to get rid of a negative, you're still going to multiply to every single term, but the easiest thing to multiply by here is just a -1. Okay, all I want to do is change the sign. To do that, you just multiply by a -1. And it's like distributing. -1 times -4x is positive 4x. -1 times y is minus y. Minus 1y if you want to write the 1 in front, that's okay. I forgot my equal sign. -1 times 1 is going to be -1. Now is it in standard form? They're all integers. A is positive, and it's in the correct format. So this is my final answer. Make it transparent. Okay, so there's my final answer. All right, so we're going to say that for our homework, which I'm going to say is going to be due Wednesday, the 8th, try all of these U-Try slides on this homework assignment that I'm going to be posting, okay? They're all the same types of problems that I just did. Look, drag and drop the matching slope. Write an equation in point slope form. Write an equation in slope intercept form. A horizontal line, a vertical line, and a couple of standard equations, okay? So give them a go. If you run into any issues and the video isn't helping you complete the homework, you can send me a message on Google Classroom, you can email me, and if corresponding electronically like that is just not working and you would like to touch base, like face-to-face sort of, send me an email. And we can actually do a one-on-one Google Meet, and we can kind of chat that way. Okay, so give them a go, and I'm around if you have any questions. Take care.